Shown is the graph of y equals f of x. On the same axis, sketch the graph of 1 over f of x, so the reciprocal. So we start off by looking at where there are roots on the original function, means we're going to have asymptotes on the reciprocal. And the reason for that is because if f of x is equal to 0, when we do 1 divided by 0, we're going to get an asymptote. So again here, we're going to end up with a vertical asymptote going through there. Now we have to look at what's happening on the graph. Now, as this one gets bigger and bigger and bigger, 1 over f of x is going to get smaller and smaller and smaller. So this tends off to there. This one is actually going to come along here. And as this gets closer and closer to 0, 1 divided by some tiny number is going to get really, really big. So it's going to go off to infinity. So we end up with this kind of bit here that looks something like that, with that horizontal asymptote there too. We can do a similar thing here. As this goes off to infinity, 1 over that becomes tiny. And as this gets closer to 0, 1 over that becomes huge. So we get a similar thing on this side that does something like that. Now let's think about in the middle. 1 over f of x. All of these values are negative in here. So it's still going to be negative. So it's going to be below the x-axis. The smallest value on this function is at -4. So when we do 1 over -4, we get a quarter, minus a quarter. So that means this minimum is going to become a maximum about here, at minus a quarter. The x-coordinate has stayed the same. This is getting closer and closer to 0. So 1 over something gets closer to 0 tends to infinity. And similarly on this side is going to tend to infinity. So this graph comes up, bends round and has a maximum at that value there, and then bends back down. And notice that it is quite a bit flatter than the parabola shape at the top. It is quite a bit flatter. That is normally what happens with these. Marking the point in roughly the right place is really important, and the asymptotes as well. So that's how we draw the graph of 1 over f of x when we have the original function. Roots become asymptotes, minimums become maximums. As the graph, the original function tends to infinity, 1 over f of x tends to 0. As the original function tends to 0, the reciprocal tends to infinity. And using those, we should be able to sketch the graph of any function we're given.